Hey Chem class, I just wanted to introduce you to the lab you're going to be doing over the next couple of days, which involves some mystery reactions. All of those reactions are double replacement reactions. If you can remember, in a double replacement reaction, we have two ionic compounds, cation, anion, another cation, another anion. And in these reactions, what we see are the cations switching places and forming new compounds. So our end result turns out to be two new ionic compounds. And as we learned previously, the products of such a reaction are usually either a gas, water, or a precipitate. And for this lab and in general, we are going to focus on double replacement reactions that produce a precipitate. So let's take a look at the reaction that is guiding this investigation. Here we can see two clear liquids being combined, one in the test tube, one coming out of the dropper. And when those two clear solutions combine, we end up with a yellow precipitate. If we were to allow the test tube to settle over a few minutes, we would find that that yellow substance would fall to the bottom and turn into a yellow powder. Again, since it falls down through the system, it's called a precipitate. So the first thing that you were asked to do in your pre-lab is to try to come up with a preliminary claims, evidence, and reasoning for that chemical reaction. You might have said something like this. The claim is that the reaction formed a yellow precipitate. The evidence would be that two clear solutions were mixed and a yellow solid was formed. Your reasoning might have been that a precipitate is a solid that can form when two ionic solutions are mixed. So hopefully you can see here a little example of the progression from claim to evidence to reasoning. The driving question that you're being asked to think about in this investigation is how scientists can predict the properties of products of a chemical reaction, and also how can they design chemical reactions in order to produce products with specific properties. So this is basically all of what chemical engineering is about. How do we take raw materials, reactants, and turn them into the products we want that have the properties we want? And on a very small scale, that's what you're going to be seeing in this investigation. And what chemical engineers will do is look for patterns. So in this investigation, we're going to combine solutions of compounds that we know the formulas for and see what results we get. Then we're going to see if we can find any patterns in those specific combinations of compounds. And that's going to allow us to try to predict what the products are of new reactions that we didn't do in the lab. In this table, you can see the answers to your pre-lab in writing the chemical formulas and the cations and anions that we'll be dealing with. This investigation is done on a micro scale, and I'm just going to show you a couple of seconds of what you would have done if you were in the lab. So if we were in the lab, we would have set up all of our 10 chemicals with small micro pipettes for each one of them, and you would have taken those pipettes back to your lab stations and performed the chemical reactions at your tables. And you would have done it in a micro scale, which means you would have used just a couple drops of each of the reactants in order to see if there's a reaction. And by the end, you would have a complete reaction table right there on a piece of paper. So instead of doing this in test tubes where we would have to use a lot of each solution, we just use a few drops of each solution. And we use a sheet of paper covered with a sheet of plastic in order to observe the products of the reactions. Your data for this will depend on what you observe. So for example, this is one of the reactions that you're going to see. And if this were the reaction you were writing the data down for, in the data table, you would write blue precipitate because that is what you saw in the reaction. Once you've written down all of your data, that's when you're going to begin to look for patterns. So you want to compare the reactions that have the same cations with specific anions and see which patterns you can find in those reactions. So this is what the full data looks like. You have a copy of this in your OneNote lab. It's just to the right of your actual data table. So you can take this and examine each square and write the data in on your data table. Again, there's either going to be no reaction, in which case the solutions will both remain clear, or you're going to see a precipitate, in which case you should write the color of the precipitate that you see. And the last possibility is that the entire solution might also change color. So sometimes you have, as we saw before, a yellow precipitate in a clear solution. Other times you might have a white precipitate in a brown solution, or maybe a yellow precipitate in a blue solution. I've never seen that, but that would be interesting. So anyway, that's what you're going to write for your data, and this is how you're going to start to look for the patterns in your data. Now, if there's anyone that you're not quite sure of, because I understand zooming in on the resolution of this picture may make it difficult to determine if a reaction occurred or not, don't worry, I'm going to give you the data after you've done it. I just want you to have that experience, though, of looking at the data and making the decision yourself as to what you saw. The post-lab questions are going to ask you what some of the patterns are that you observed in your data. And I'm just going to get you started off with one so that you understand what my expectation is. You're going to find that reactions that contained lead to nitrate tended to all generate precipitates. So that's one of the patterns that you would be looking for. Along this line, you should generate probably 3 to 4 other patterns that you can observe in your data. Based on those patterns, you'll have an opportunity to add more detail or revise your original CER based on the reaction between the lead nitrate and the potassium iodide. Then you're going to move on to investigation 2. This is when you're going to see these mystery chemicals come into play. So we're going to use 8 unknown solutions, and they are 8 from the original 10. So they are 8 that you know, but you don't know which 8 are being used. Once again, we're going to perform all of the possible reactions between the solutions and again record that data and use the patterns in that data to try to determine which compound each solution was. That's the mystery, right? So this is what the data table looks like for investigation 2. And based on this, again, you want to be looking for the patterns in the data and try to match those patterns back to what you learned in investigation 1, where you knew what the solutions were. You're going to have to do a little thinking here. You're going to have to do a little reasoning, use a little logic, and use those previous results and try to figure out what each of the 1 through 8 compounds actually is. And again, they all are compounds that you used in the first investigation as well. Once you figure that out, you're going to try to identify what each of your mystery chemicals is. After you've done that, they provide for you a table which gives some general solubility rules. Those general solubility rules should be used to make revisions to your original table. So let's say you decided that mystery chemical number 1 was sodium chloride. And then after looking at the solubility rules, you decide, you know what, maybe it's not sodium chloride. I think I'm wrong there. Please do me a favor and cross out what you put in and revise to a more final answer. So I would definitely like to see your mistakes, so to speak. I would like to see your first guesses as to what each chemical is, and then go back and use that solubility rule to try to identify them more carefully. Once you finish this part of the investigation, you'll head into the final set of questions. There, you will be asked to give me these final identifications for the mystery compounds. You're going to get one more chance to revise your CER, and you're going to write the full equation for the reaction between potassium iodide and lead nitrate. So that's reactants and products with their states of matter. You're also going to have a chance to reconsider what the driving question was. Again, how do scientists create reactions that produce products with the properties that they are desiring? Up next after this, we'll be practicing predicting the products of double replacement reactions. And don't forget, next week we are having an assessment that will cover identifying reactions and predicting single and double replacement reactions. So keep practicing those skills.